a board that provides some information about something. These card signboards are important to provide information such as direction, destination and distance. The signboards are designed using particular geometrical shape which improves their visibility, readability and recognition. The geometrical shape that we selected is located at Tuanku Bainu Library at Universiti Pendidikan Sultan Idris, which is the library are important place for UPSI students because it provides the resources of learning and research. The main purpose of guide sign is used to provide critical information, direction and warning using the visual display. The function of the signboard in our report is the guide sign played an important role in guiding students, staff and visitors around the campus efficiently. Signboard is used to indicate the location of faculties, lecture halls and room, library, administrative office, hostel and other important facilities. The size of the signboard we selected, we got a distinctive present shape. The measure of the signboard we got 0.8 meter multiplied by 0.13 meter multiplied by 2.0 meter. The head of the guide signboard must be high so that the right turn of the word are clearly visible. The purpose of manufacturing size to make it easier for students, especially new students, to refer to it.
Continue our presentation, I will be explaining about section 2.0, which is the geometry of the perpustakaan Tuanku Bainu signboard. This analysis includes both the primary structure and the geometric shapes identified in the signboard's design. So let's start with the primary geometric structure. The signboard's primary display panel is essentially rectangular in design. The library name is displayed in Arabic, script, English and Bahasa Melayu. It is rectangular shapes, which offer the best canvas for multilingual text display. Rectangular form has various benefits, including better text distribution throughout the display panel, clear visual border and a maximum readable surface area. Now let's move on to the 2D geometry shapes. The most prominent is the rectangle, which forms the main vertical face of the signboard. A rectangle is a quadrilateral with equal opposite side and 4 right angles. This shape ensures that the text appears clear and balanced on the signboard. Next, we have the logo of the UPSI at the top of the signboard, which is a circle. A circle is a two-dimensional shape whose points are equidistant to the center and which represent the unity, completeness and also the continuity. This figure contrasts compared to the angular forms and attract the attention to the identity of the university. The signboard also features multiple trapezoids, adding to its modern looks. A trapezoid is a quadrilateral with at least one pair of parallel sides. The signboard includes two trapezoidal shapes that add a dynamic and modern. Next, we also have the hexagon, which can be seen in the blue pattern here. The hexagon is a polygon that has 6 sides and internal angle measure 120 degrees. The hexagons are often used as Islamic geometry pattern and it makes the design look intricate and elegant. Within the blue pattern, you can also spot pentagons and kite shapes. The pentagon is 5 sides and contribute to the decorative features, while the kite is a 4-sided figure with 2 pairs of edges inside the post. These shapes have traditional cultural elements which reflect the Islamic art patterns. Within the blue pattern section, a pentagon shape can be observed. A pentagon is a 5-sided polygon and in this signboard it appears as a part of the decorative motif, which contributing to the geometric richness and visual interest of the design. The pentagons are arranged in a repeating pattern, enhancing the aesthetic appeal of the signboard. Next, a kite also forms part of the blue pattern. Moving to 3D shapes, the main body or the supporting column on the signboard, the 2D design is a 3D dimensional rectangular prism, or we can say also as a keyboard. A rectangular prism is a solid with 6 rectangular sides, where edges and 8 corners. The side of the rectangular prism are parallel and the same side, but both sides are rectangle. The length, width, and the height remain features of the rectangular prism because they shapes. This is a 3D design that provides high stability and strength to the signboard. Next, there are also a trapezoidal prism formed when the 2D trapezoid are extruded through the thickness of the box. The signboard contains two trapezoidal shapes that form trapezoidal prism.
A rectangular prism is a 3D shape where all the faces are rectangles. It is also known as a cuboid.
For the perimeter of the rectangular prism, we can only sum up all the 6 faces of the prism, including the 3 pairs of the identical faces. For the top and bottom of the prism, the width and length are 80 centimeters and 40 centimeters. For the front and back of the prism, the width and length are 80 centimeters and 190 centimeters. And for the right and left of the prism, the width and length are 40 centimeters and 190 centimeters. For the lateral area, we can use the base perimeter calculation we got from A, but we just use the base perimeter. So we substitute the value into the equation, which is L equals to H multiplied with P. The H is the height of the prism, which is 190 centimeters, and P is the base perimeter of the prism. We substitute the values. L equals to 190 centimeters multiplied with the base perimeter, the width of length of 14 centimeters and 80 centimeters. For the total surface area, we can just substitute the values we got from perimeter and the lateral area into the equation. So the equation for the total surface area is A equals to L plus 2B. L, which is the lateral area, and 2B, which is the 2 base perimeters. As we substitute the value, L equals to the values of lateral area, and 2B is the base perimeters of the prism. So lastly, we substitute a value for the volume. So for the volume, the equation is V equals to length, width multiplied with width and multiplied with height. The height being 190 centimeters, the width being 40 centimeters, and the length being 80 centimeters. Now we substitute the values into the equation, and it will be V equals to 80 centimeters multiplied with 40 centimeters multiplied with 190 centimeters.
The trapezoid is a quadrilateral, which means it has 4 sides. But what makes it special is that it has exactly 1 pair of parallel sides. These 2 parallel sides are called the bases of the trapezoid. The other 2 sides, which are not parallel, are called the legs. In the case of the Perpustakaan Bangku Bainu signboard, the blue part of the signboard is an isosceles trapezoid. So to find the perimeter, we just sum up both the length of the legs and both the top and bottom bases. The top base of the trapezoid is 55 centimeters, the bottom base is 160 centimeters, and the legs are 95.7 centimeters each. For the area of the trapezoid, we measure the height of the trapezoid, which is 80 centimeters. Now we substitute the values into the formula, which is 1/2 multiplied with the summation of both the bases, top and bottom, and multiply with each the height. A circle is a 2D shape made up of all the points that are the same distance from a center point. Let's break down the parts of the circle. Firstly, the center is the middle point of the circle. The radius is the distance from the center to any point of the circle. The diameter is the longest straight line across the circle passing through the center. It's actually twice the radius. The circumference is the distance all the way around the circle, like the perimeter of the other shapes. And lastly, the area is the space inside the circle. From the diagram of the signboard, we can see the circle shape at the top right, which is the UPSI logo. We measure the diameter of the circle, that is 14 centimeters. So first, we calculate the circumference of the circle. The formula of the circumference is C equals to 2 pi r. For the radius, we took help from the diameter, which is 7 centimeters. So we substitute the values into the formula. After finding the circumference, we proceed to finding the area of the circle. The formula of the area of a circle is pi r squared. We substitute the values and get the area of the circle. A star is a shape that usually has 5 or more points. The lengths of the points and the angles between them can be different, especially in an irregular star. In the case of the signboard, it is an irregular star. So, to calculate the perimeter, we need to sum up all the lengths of the sides of the star, and then we get the value of the perimeter of the star.
The concept of geometry of hexagon. Hexagon is a polygon is a closed plane figure whose sides are 9 segments that intersect only at the end. For the measurement of hexagon, we got the length of each side of hexagon. We got AB equal to FA equal to 9 cm, BC equal to CD equal to 3.5 cm, DE equal to EF equal to 7 cm. And the interior angle for this hexagon we got 720 degree, and the perimeter of the hexagon we got 39 cm. We go to a pentagon shape. Pentagon is a shape that has 5 sides. The figure shows the pentagon labeled as A, B, C, D, and E. Each side is connected to form this shape. As you can see, the line AB and AC has measurement of 70 cm. BD and CE have 18 cm. And last one, DE has 22 cm. When you add all these sides together, we can know the perimeter of the pentagon, which is 92 cm.
Next, I will talk about transformation in motif and pattern. For this, I will be used example from the Tuaco Pioneer Library signboard. Before that, let me explain what is motif, pattern, and transformation. A motif is a basic design element such as a shape, symbol, or image. For example, we often see motifs in the form of star, pentagons, hexagon, and other geometric shapes. Next, a pattern. Pattern is formed when these motifs are repeated or arranged in a structure and organized way. A transformation means changing the position of orientation of a shape without changing its shape or form. There are 4 main types of transformation. First, translation is moving the motif from one position to another position without rotating or flipping it. Second, reflection is flipping the motif over a line to create a mirror image. Third, rotation is turning the motif around a fixed point by a certain angle. Fourth, dilation is resizing the motif while keeping its shape. Let's begin with the first type of transformation, which is reflection in motif. Here, we can see a line CH is a line of reflection and also known as a central line or mirror line. This line is like a mirror that flips the pentagon shape to the other side. That means each point A, B, C, D, and E on the left side is a corresponding mirror image on the right side, which is P, Q, R, S, and T. This is called as vertical reflection because the flip happens over a vertical line. You can imagine like how your face appears in a mirror. Now, let's look at the next transformation, which is rotation. In this example, we can see a star motif is rotated in 180 degrees around a central point. This means the shape is turned half away around a point, so it ends up facing the opposite direction. People thought the star has turned, it does not change its size or shape. All the point, angles, and sides stay the same, but only the direction is different. This shows that the rotated shape is congruent to the original one. That means star A, B, C, D, E, and star P, Q, R, S, T is the same shape. Last but not least, we have the transformation in pattern, which is a reflection of right trapezoid. In this example, we can see the right trapezoid A, B, C, D is refracted across line GH to form a new right trapezoid, which is PQRS. Just like in the previous example with the pentagon, each point from the original shape is the same distance from the mirror line as its image. For example, point A and point B are equidistant from line GH. This means they are the same distance away but on opposite sides. This kind of reflection creates perfect mirror symmetry where the shape is split but still stay in the same size and form.
In conclusion, all the geometrical shape is all around us, whether we notice or not. Architects and designers use geometry to create buildings and objects, just like design what we study. After all, this assignment helps us a lot to learn new skills such as teamwork, communication, and measurement data. That's all from me, and that's all from our group. Bye-bye!